So good morning, everyone. It's a pleasure to be here at the AI House in Davos to welcome you for our panel, in and beyond LLMs. That we have Gen AI is more than LLMs, Swiss innovators shaping the AI frontier. If you took a walk down the street here in the previous few days, you have read everywhere AI and agentic AI. So we have the impression that you take an LLM, wrap it together with some interface, and you have a machine that solves basically any problem. That you have a machine that tackles anything, it works, so all problems are solved. AGI, so general intelligence, is just artificial general intelligence is about to arrive, and there's no more else to do. And in this session, we would like to tackle this problem and challenge this notion that just LLMs plus some tools will solve all the future. And in this discussion, we will focus on manufacturing and engineering and design with artificial intelligence. And we have three amazing startups here. So we have EthonAI with Bernhard, we have Chipmind and the CEO Harald, and we have Philip from Raven. And they're all working on how to use AI in a generative sense for design, for chip design, for CAD design, or designing manufacturing, supply chain manufacturing outlays. And in this panel, I would like that we start that the three gentlemen introduce the company, how they do Gen AI, how this probably differs to the notions we have of Gen AI from LLMs, because LLMs are just token generating machines, and explain why this has a real world impact. Because everybody is talking about artificial intelligence, very few are talking about the return of investment in its impact on productivity. And since the Swiss are often more humble people, all those companies are working on real-world impact because it's the only way to survive as a European startup. And with that, I would like to give the first word to Bernhard, that he starts introducing his company, his vision.
Yeah, thank you, Florian. Hi, my name is Bernhard. I'm the co-founder and CTO of EthonAI. We are an industrial AI platform. We are developing an industrial AI platform that helps manufacturers, in very simple words, produce more with less. So optimize for quality, optimize for throughput, anything that drives costs on the shop floor. We're working with, for instance, Siemens, Bosch, Roche, Swiss watch makers, different types of industries. And how do we do Gen AI? How do we do AI in general? We are tapping into all the different data sources that these manufacturing companies have. We are contextualizing them with a knowledge graph, with an ontology, and then we are having causal reasoning models that are deriving insights. So what drives quality, what drives cost, what machine settings to optimize. And with that foundation, we can now build agentic workflows on the top that are actually industry safe and can drive results for process optimization, root cause analysis, visual quality inspection, early fault detection. So all these kind of different use cases that drive costs. And yeah, that's it in a nutshell.
Harald?
Thank you very much, Florian, for the invite. So for Chipmind, it's the first time here because last year, this time we did not yet exist, so we're pretty young. Both founders spent around 15 years in the semiconductor industry as engineers and product managers, and there we found out that taking chips is too much of an effort, and it takes too long. Like it's usually 4-year cycles to develop chips, and meanwhile we also saw that software development gets a lot of productivity enhancement tools, all kinds of assistants and co-pilots over the years, and the development of chips was kind of left behind. And that's what we are about to change, and that's kind of our story in a nutshell. So kind of what Chipmind does is we accelerate the development of microchips. It means we deliver or we build solutions for top-tier European semiconductor companies where our AI solution accelerates the development processes of chips such that chips hit the market faster. And yeah, said we are a pretty young startup, and kind of at the moment we we get a lot of interest, of course, because the chips, since the GPU kind of getting famous, there is a lot of attention where kind of a lot of people care more about chips, whereas like 5 years ago, a chip was really something which was just in your pocket and you never cared about it. So yeah, really happy to be here, and thanks for the invite again.
Philip.
Yeah, thanks as well. Happy to be here. I'm Philip, co-founder of Raven. We're so young that we don't even, I couldn't say I'm CEO or something because we haven't sorted it out, kind of, you know. So let's stick with co-founder. We are a AI co-pilot for CAD, right? Computer-aided design is basically the planning software you use as an engineer or architect to produce something. Maybe for the story, so you understand, I'm an architect myself originally, very boringly, no software, because I'm actually interested in products that exist in reality and work in reality, right? I worked as an architect, got very, very frustrated very quickly because, of course, in university you go, oh my God, I'm going to change the world, you know? And then you end up working and you build villas for rich people somewhere in Munich and you realize, where's the impact actually, right? So when AI came up, me and my co-founders, we decided, let's have a look and see if we can have like actually an impact with AI in our realm. So what we're trying to do is really, you know, things that are working in reality and need to work in reality, they always have a digital representation of themselves before they are transferred to reality. And coming up with this digital representation is a CAD model, which takes a lot of time to produce. It's very complicated. You need a lot of training. So that's why we're a co-pilot, basically at the end of the day, accelerating model timing, but also making it way more intuitive, you know, quickly iterating, bringing back fun basically to designers and architects.
So very good. Now we basically know what they do. Probably they don't know how to organize themselves, but they have at least a vision. In the first part of this discussion, I want to talk into this topic AI beyond LLMs in industry and beyond the hype. So the first question I have to all of the three panelists is, what AI technologies beyond LLMs are powering your solution and why they are essential for your domain? So what sets you apart from thousands of other startups that wrap some LLMs and do something with some interfaces? What makes you different and why is this impactful? And at first I'd like to start with Harald, because chip design is probably most alien to all of us here. CAD is probably better known because at least we know a building, and then we would go to Bernhard.
Yeah, right. So how shall I put this? You can imagine a semiconductor company is a large company who has a lot of code, a lot of stuff in there, complex processes for different parts where the chip is developed. And these processes, they have evolved over decades, and the chips are kind of released iteratively. There's one chip, then there's a new version, and sometimes also a new version is created from scratch. That's kind of what happens at the development at the bottom. And this development environment looks the same since decades. It looks like in the 80s, basically. It's really like Unix type style black environment. And then at the top, there come LLMs in there from hyperscalers, where kind of we see, okay, the LLM intelligence is plugged in like electricity. There's endpoints to intelligence one of a sudden. And then in the middle, there's the gray area where these LLMs at the top cannot really solve tasks at the bottom in this environment. And no one is really putting these together carefully because, of course, as you can imagine, these environments are very heterogeneous. There's semiconductor company A, semiconductor company B, all legacy-grown stuff. And that's kind of the area where we create value with our agents.
For us, it's basically, so three things, right, on top of LLM. It's basically symbolic engines, computation, basically. How we organize our data, which is as a graph, and then also repetitive tasks, which basically have a solution, you know, you can store in a database and like surface when you need it, right? To like elaborate a little bit on this, the first one is symbolic engine. So, you know, CAD is basically geometry, which is math. So it's a symbolic equation, which is very deterministic, actually. So we take an LLM, which is basically not deterministic, to go around a logic of something, how it should look like. By the way, we're doing, of course, buildings, but also, you know, as I said, everything that needs to be in reality at some point, so from jewelry to a boat or whatever. And we reason about how this should look like, but then we convert it or we structure it in such a way that it is a graph, which is the second thing, and then we put it through a computation engine, right? So with this, we make sure that we basically really validate that this works in reality. And of course, you know, the LLM can come up with something that's crap, make errors or something, but in a loop where we have always this computation feedback, we can actually fix the code, kind of, right? And come up with something that at some stage kind of like passes the stage gate of, okay, so this works. Last one is with the repetitive task. I guess it's something we all have in common. So yes, a building is always something individual, but at the end of the day, it has a roof. You know, how it is connected to the wall is like similar sometimes. So what we are doing is we're building up this database of very generic models, right, that are parametric, so can be edited towards what you need in terms of measurements, for example. And then you need to like rag through this, surface them. Oh, I need this now with the roof and the wall, for example, and combine it with the overall model that I have.
That sounds super interesting. We are actually in the step after you. So when the chip is designed, you want to manufacture it, right? And in these types of environments, it's very hard to make LLM predictions because you're in safety critical processes, heavily regulated industries. So one thing we have invested in very early on is what we call causal AI. It's AI that can detect real cause-effect relationships in data. It's something actually coming from medicine where you're treating a patient and you want to know which of these treatments that you gave to a bunch of patients is actually causally, you know, the result of the patient being healthy at the end. And we see shop floor processes as nothing else than a patient. These processes can be healthy or they can be unhealthy. The quality can go down, the throughput can go down, things happen, right? And then you have all the operators and process engineers on the shop floor, and they actually have a lot of tacit knowledge, and they're starting to push buttons and turn knobs when the patient is unhealthy. And all of these are recorded in your data, hopefully. And when you then take this data, we can tell you which of these interventions that people actually run on the shop floor have a causal impact on making the process healthy again. So we are doing two things. We're obviously driving the health of the process, but we're actually also like distilling out the knowledge that shop floor operators have and that frontline workers have and process engineers have. And we can then automate that with agentic workflows and suggest the right interventions at the right time when stuff happens again.
So when Harald said the hyperscalers are offering us AI like electricity, I like that. So this brings me directly to the next question: domain specialization versus general AI. So why are specialized AI systems outperforming general purpose models in your vertical? Why we cannot have simply a plug and play solution coming from Google or from OpenAI or from Mistral in France, and the shop floor problem would be solved? So Bernhard, what would you say why there's no plug and play general intelligence around?
I mean, two reasons, right? One, I've briefly touched upon, we are talking about safety critical processes, right? So every intervention I run on the shop floor directly has an impact on the health and the safety of everyone who is working around these processes. These are heavy machines, high voltages, high temperatures. You cannot just randomly put them at fantasy values. At the same time, the products you produce are heavily regulated. We're working with pharmaceuticals. We're working with fire detectors. You don't want these products to fail in the field. They are, again, impacting the health and the safety of patients, of everyday life, right? So it's a heavily regulated environment, and you need to have AI models that are able to be constrained to the safety of that field. And the second part is tacit domain knowledge and other type of knowledge, right? I think we need a type of AI where everyone can fuse their knowledge. Like, you have been manufacturing these things for the past sometimes 20, 30, 40, 100 years, right? There's so much knowledge in the head of people, in standard operating procedures, in recipes, in SKUs. You have all this information out there. you want that to be incorporated into the AI model that actually makes the decision. So I think these are the two main factors why off-the-shelf ChatGPT tell me how to fix my machine. It doesn't really work, why you need a bit more of an industry-tailored approach.
Yeah, but when I think about your chip problem, this general AIs are trained in software, so they have seen a lot of Python and Java code. They probably have never seen a chip design software programming system, I guess. Oh, or am I wrong?
No, right. That's absolutely the case. So is the generic agents and co-pilots, they work well for software development and for for generic Q&A, also to develop apps and web apps and so they're made for that, because of course naturally there's like 27 million software engineers and just 300,000 chip design engineers. So naturally there's a bias towards that. And yeah, why they don't work well for chip design? I mean, that has several reasons, and I think one important reason is that chip design is something. There's the term design in it. It's something physical, which has dimensions. It's really literally has like. It's not just sequential code executed one instruction after another. It's something where there is a geometry in there and physical substances, which also then require a different user interface, where a textual user face is not any longer the optimum way to interact with. And the other thing is, of course, as probably for any other domain specifications, is that a lot of context is missing in between, because what a lot of engineers do in meetings all day long, they provide other engineers or PMs or whatever team leads in context, and they provide context back such that decision can be made. And so there is, of course, a lot of context missing, and that is the second part, which is different. And the third one is that sometimes the generic solutions, they are targeted at hobbyists or engineers who work themselves. Let's say the development is centered around their mind, their IDE, and their desk, and starts from there. Whereas in a development flow in an enterprise, that is not the case anymore. There, it's just very fine-grained dependencies linking into each other, where not every node in that development flow has an IDE anymore. Whereas when someone develops an app, that approach is very good. So I think these are the three reasons why the generic approach in chip design does not work really well.
Yeah, you mentioned you need real physical and geometric models, and I'm teaching at the Fachhochschule, and I made an experiment. Let students use the LLMs to play chess, and this works up to move 15, 20, and at this point, all the LLMs start to make illegal moves. So not even understanding as something as simple as chess works well. You can then, of course, do a chess engine and bring it back and tell it's an illegal move and so on. But from text as a representation, to understand something as complex as geometry or mechanical interaction, shear stress and that stuff. And so how do you go about this, that this actually work? And where's still maybe an LLM, and how do you embody the physical, real-world geometric representation in what you do at Raven?
I'll answer this. I just wanted to ask into the round real quick. So, who would have ChatGPT build their house? Probably not, right? So that, like, I guess maybe it's a fun experiment, right? But like,
no, those who haven't survived.
Exactly. Maybe they're not here anymore to say I would have. But anyway, it's really so, you know. Before I answer this, right? So what is why actually, right? So, and I think, I mean, the LLMs are trained on what's out there in the internet, right? But when you build a house or when you model a jewelry or something, I mean, that's something very human, right? So you have a lot of knowledge trapped, so to say, not scalable in individual heads of these individuals who have done this forever. So even like a construction worker, how he applies the plaster around the window, whatever, is not really written down anywhere. So that's why that's one of the main reasons why this doesn't work, right? So how we go about this, it's basically what I said earlier, right? So we take we try to give the LLM as much constraints as possible to kind of make sure that it applies to these rules that are out there, right? In a very generic sense. So, and how do we do this? Again, basically by running these validation computations, making sure this actually works, but also by working with the community. So I think we'll touch upon this also later, but we are a co-pilot. We're not automating away architects or designers or engineers. So it means in organizations, for example, what we have is before you have a bottleneck of exactly this trapped human knowledge, what we do is it can give it basically to Raven, and now we can scale this knowledge across the organization. So before, in a very concrete example, I'm in an engineering office and I need to have this structural optimization done with this beam, right? Like shit, how did that work again? Like math, I hate it, you know? So I always go to this expert of the computational design team, for example. But this is the bottleneck then, eventually. So now when I scale this knowledge across my team, I can make sure I just ask what I need, and then again, I can like go in the knowledge base of this organization and surface this knowledge, and basically give it as a partner to the LLM, if that makes sense.
From what I heard from all of you three is there is a ton of implicit knowledge around, be it at the shop floor, be it in the different design patterns. And since text is not the only workable representation, and the LLMs have made this huge impression because they work extremely well on software, but software in the end is very, very narrow because any software language has a very, very limited syntax, a very, very clear specified semantics. So you really know what it's doing. And that's why I want to go in the question of multimodal AI integration. So because the knowledge and the way you go about in your different domains is so broad. So which different AI modalities are you integrating? What are you using from vision, reasoning, agents? And then how do you get to something that works coherently, that you have a coherent systems that actually drives then productivity, actual results? And I would like to start with Bernhard.
Mm-hmm. Thank you. It's a good question. What we do is we have the data. First of all, let's start with the data. Then you're contextualizing data with a knowledge graph. So we're building.
How do you collect the data? Is there a vision, or is it how is it from manufacturing system? How do you get the data? So
that's usually the part that differentiates for every one of our customers, because they all have different sources out there, right? There's all this legacy IT stack out there, and you need to kind of get that data in. We also have computer vision models that generate data. So like models we can deploy on the shop floor that measure actually the quality of a product, to tell you are there scratches, are there dents, is the product correctly assembled. So we take all that data, we contextualize it with a kind of an ontology. It's a bit the Palantir move. You tell the AI models above what actually these individual data sources, what are the individual contexts. When there is a field return of a product, you know at what place was it, with what batch has it been manufactured. So you have all this contextualized. And now we're building these industry-safe models on top that do like time series anomaly detection. They're doing root cause analysis, all these different types of things. And now you have these models that are safe to be applied in an industry context. And now you can start to orchestrate them with LLMs. And that's where I think agentic workflows goes from a pure hype word to actually driving results, because you can now have an agent that says, I'm monitoring your quality, I see this quality is dropping, now I'm starting an analysis, and this analysis again comes from an industry safe model. But when the analysis results come back, the LLM again can tap on all the process descriptions or the SOPs that are out there to enrich the analysis results. So I'm not only telling you your temperature went down, I'm telling you that, oh, your temperature went down, and actually you documented that this temperature drop has this and that effect. And now you can basically go from a purely firefighting mode where you're on the shop floor and you're just like looking where is the light blinking and how do I fix that, to a more proactive mode where you can go look on a screen and you can say, hey, I see your quality slowly starts to drift. I think this is actually caused by the temperature in your preheating machine being out of bounds because someone opened the door 10 times in the last 5 minutes. And then you start to actually see results.
How do you acquire all this different data in the chip field?
Yeah, for us, if you recall the the setup from previous, okay, we have the LM plugged in like electricity at the top, and at the bottom is the channel, all the chip design resources of the environment. There we have our mechanism to kind of to abstract all the design and also the flows and all the artifacts which were generated, and then we create an abstraction layer. I don't want to use the word ontology now again, but we create something there which kind of provides input to the agents to operate. So that's kind of how we put this part of the data there. And then there's like two other aspects. One is then, which is important for chip design, there is a lot of tools involved, like say custom tools for example, to synthesize part of the chip or to simulate part of the chip. And these tools, they produce output. And that output then again produces data, and that is not really textual output. I mean, it's kind of binary data sometimes, or tabular data, but it's not like written text which says, okay, I've simulated correctly because of this, or I've simulation failed. So it's then one of these outputs which is kind of a bit multimodal, which then we also process. And another important part of our data is, of course, our trajectories, let's say, because in chip design there's a lot of tasks executed, and how do you represent tasks in an agent system represented with trajectories? So kind of you need a lot of trajectories which are kind of representative for what's going on in that environment. And so these three types of the data, they work then together in this system, such that a custom model is not really required anymore, because also a custom model is something which is very cumbersome to maintain and to evolve and to scale over different customers. That's how we kind of deal with that, and so far it has shown to be kind of a really good approach to kind of to build an agent harness around what is there. Okay, there is intelligence at the top and there's an environment at the bottom.
Thinking about architecture and design, which is inherently a human manipulating something it sees. It's a vision task. How much vision are you using, or is it just all parametric models and simulations? How do you have vision and other modalities used to co-pilot and support the architectural designs?
So we basically, from the framework side, kind of we have two loops in place, right? And the one loop is really using all the weapons there are, kind of, which also includes diffusion models, so vision models. So basically, as you said yourself already, right? In the beginning, like our input that we work with is design intent, and that design intent can be a text, it can be voice to text, of course, but it also can be a sketch. And when you have a sketch, you of course first need a modality of a vision model to really like understand what's going on there, right? And basically from this translate back a geometry and a path to get to this geometry. So we're using this, and also later in this loop, for example, we have of course in the CAD software the representation of your geometry basically, and we're doing screenshots of this basically and feeding it back to the loop also to check how does it look like, does it look funny, because sometimes the code might look okay, but the result is still funny. So you need this additional input also, which then does a vision model, right? I said two loops in the beginning because so the one loop is really design intent. You take a reasoning model to really go about the geometrical path and logic about this. We do a query to our database, what you can use. We do a query to basically the tools and parametric components that we have in the CAD software. And then we do the computational design, or the computational thing, which is nothing to do with AI. So we kind of like run and fix in a loop again. And then we get it back to the user, and most often also have to explain it because it can become quite complicated. The other loop is the human, right? So it's really, we are not doing a one-shot thing. So it's not like image generation, where you basically can say, I want to have this funny Trump on Greenland image, and then it gets back, but I said, oh, but like I want Trump to be bigger, so I have to go back to the prompt and do it again and hope it works. This would never work with architecture or CAD in general, right? So basically, what we're trying to do is, with visual scripting, making the code and everything that happens in between, open to you, and then of course you can iterate on it as a human again and again and again for days and weeks. A CAD model stays relevant quite some time, and this loop is also very important, of course.
Very interesting. Coming here, I want to switch gears, and coming here to Davos on Tuesday on the first train, I was reading a PwC or Ernst & Young, I don't know, one of the big fours study on the impact of AI on the economy. And they queried 4,000 CEOs of the 4,000 largest companies. And 3/4 said AI will lift productivity. On the question later down, how many think AI materially transforms their industry in the next 5 years, 30% said yes. And on the question, who has seen material AI benefit, 9% said yes. So the whole thing, AI is all cool, can be very academic, but a startup and a company is not an academic institution. It's there to drive efficiency and gains for clients. So that's why I want to ask, in your specific domain, AI as a productivity tool. Because this type of money that is flowing in AI will stop if we don't see tangible results in, I don't know, next year, basically, or this year. I think we need to get from experiments and proofs to material results. And that's why my question is, what concrete productivity gains have you measured, and how do you demonstrate return of investment in your specific customer field, or what you believe you can achieve? What is the tangible benefit of using, I want to start this time with Philip, of using Raven in an architecture shop?
Sure, yeah, maybe I have to give some context, right? By the way, I'm talking a lot, and also in like very graphical images, so let me know if I need to speed up. Anyway, if you walk into an architecture office, right, what you will see is people sitting in front of their screen, everyone. What they're dealing with is their CAD model. A CAD model has a very long lifetime, so to say, right? Very early, I mean, you might have some sketches, but then you basically, you change to CAD, so to digital, and then it gets more and more detailed and detailed and detailed. And at the end of the day, when you really think it's finished, you convert it into either a plan or like a CNC file if you want to do something with machinery, stuff like that, right? So it's like all the time it's there. So if you want to, and by the way, design agencies, architects are per se a low profit margin business. Trust me, I can tell you that one. So the main lever you want to attack is CAD modeling, right? Make it more efficient. We've seen with Raven that in specific computational design parts, we can cut it down by 50%. So you can tell it's not automating. It has an impact, but we still need a human. So time is the one thing, but I guess I also want to say the other thing that is maybe not really measurable right now, at least, but I would also say we're making CAD modeling better. And the reason why I'm saying this is because there's so many nice optimization algorithms out there, for example, measuring your energy impact, CO2, structural optimization, that are important because we have all these things we want to solve, like climate change, whatever, right? Concrete is one of the, right, I guess, the material with the most CO2 emissions in the world. So when we're modeling, we should include these things quite early in our design, right? But the thing is, and again, I can tell you that no architect, no engineer will care because they are busy, they don't know how to do it, and stuff like that, right? So what we're also doing is bringing these things that have been around for 30 years. I mean, an optimization algorithm is nothing crazy, has nothing to do with AI, by the way. But we're making this intuitive to you and simply easy to use. So just do it, right? And do 5 variants of the product very early in the design phase. So I guess maybe this is something we can measure eventually, but it's also something that we are, I guess, proud of and are working on to make designs also better.
For your chip clients?
Yeah, I mean, we're of course bullish on the productivity improvements, and the challenge is how and where to show it. So for that, we use a task model. So kind of we have certain tasks selected which core in a large set of customers. And to give you an example, one of such a task is kind of I mean, each chips you can imagine has peripherals, like a USB peripheral, for example, or an HDMI, whatever, and say the task is to clone such a peripheral and to create a new variant out of a chip. And such tasks, for those we then execute it with our agent, and then we let it be solved and tested, and also run some firmware tests. That is really it's a kind of a comprehensive solution to that task. Then we measure the time what an engineer took with the agent to solve the task, and compare that time to how long it would have taken the human engineer without the agent. And then naturally customers tend to say, yeah, okay, but that is a task which you constructed and you did it, like, and then they say, yeah, that's true, but so give us your tasks. They, no, our engineers don't have time to give you the tasks, because so that's kind of the challenge, of course, because everyone is flooded with AI tools, so you don't really get easily to a realistic task. But we managed to do that for a couple of such tasks, and there the improvements we observed, they were kind of big. It was like 7x for a documentation task, where kind of the chip design, a technicality had to be synced with the PDF, like the documentation sync task, and the 14x for this task I mentioned, where we had to clone a peripheral. So I think we're fine, and we're bullish with the improvements, and if then the consultants afterwards will again adjust it, that's absolutely fine.
For manufacturing, how does this look like?
I mean, this question was actually the reason why I started to go into manufacturing, because it's, for me, one of the most honest industries that you can have out there. Either you're saving people money and you're in, or you're not saving the money and you're out. There's very little room for hype. It's extremely margin-driven. And we actually, the World Economic Forum published a paper this week on Tuesday, where we were part of the Minds cohort this year for driving results with Siemens. We rolled out in more than 20 factories with savings of about $10 million US. That's all in that white paper. So I'm really, really proud of that. And through the bench, we see like waste reductions of around 50%. We have throughput increase, 60% more batches first time right, and productivity gains on the shop floor. So yes, it takes a bit of time, and depending on the industry, this is more easy or hard to calculate. Like in process industries, it's much easier to, you measure the waste, you measure productivity, you measure first time right, you can directly translate that into dollars. Some other industries like discrete manufacturing, sometimes a bit harder, because a lot is about preventing a product recall, where, how many product recalls did you prevent this year? You're measuring the unknown, but we see ROI across our customers, and we are scaling them across Asia, Europe, and the Americas. And that's pretty exciting that we are, for the first time, seeing AI technology being adopted horizontally through these enterprises, and not just being stuck in vertical pilots.
Very good. I'd like to open the floor for questions from the audience. Who would like to ask questions to the panelists and the companies and their approaches to generative AI in engineering and manufacturing? Anybody interested? The gentleman here.
Yeah, thanks. Yeah, there we go. Thanks so much for all your insights, and wish you more than the best for your companies. I know how difficult it is to build a startup. What I see among LLMs, the development is going so incredibly rapid, and skills that are now being deployed that perhaps make parametric calculations, etc., possible. How do you keep the speed, and how do you keep ahead of the curve with industry knowledge, etc.? Because from my perspective, a lot of the use case, a lot of AI companies will dissolve within the next 5 years, because OpenAI just developed a couple of skills that can do 90% of their rubbish. Not talking about your use cases, because there's actually value in them, but a lot of the marketing, sales, and other tools online.
Maybe I can start if that's okay. Yeah. So of course it's something we have in the back of our heads, right? First off, we are working with the model developments, not against them, kind of, right? So we yes, we are more than a wrapper, but of course also we use the commoditized LLM power, and whichever is the best model, we use it. And I'm hoping that the development will still increase and go exactly as you said, right? I still think, you know, when you, for example, when you look at MCP, right? So it's the promise of any agent can operate any tool out there, and there was a hype about it last year, but it still doesn't play out, you know. So I still see a very big deviation of what we theoretically think we can do, but then actually, like on the construction side, where people build products, is it actually working, right? So for example, the MCP gives me quite a good feeling that the whole like generic approach is not working till this date. Maybe it will change. How we go about this? So I mean, we are. It's more a business decision, right? So we are becoming or working right now to become the intelligence layer of CAD, working with the existing CAD softwares, working with the models and everything, but mainly working with the customers and the users and the organizations. And by that, I guess also building our moat a little bit to whatever, you know, model we take on and whatever they've used or get to use working with us. We give them way more than simply just this one task, and then trying to stay relevant. But yeah, I guess this is what like our perspective is on that. Hope maybe we can discuss further later on. Yeah.
Yeah, for us, I think this is really an advantage because, like, I would say, like for agentic AI technology, sometimes speed is the only mode. So there's daily coming stuff in on Archive, GitHub, whatever platform. So it kind of, we provide the most value if we are the fastest ones to consolidate and that into value for our semiconductor customers, because we know that others are slower. And that kind of has to go in our company culture, into every aspect, into hiring, into how we do the meetings, into who does what on a weekly basis. So kind of that is really essential. And because it's essential that everyone avoids to make a lock-in or a horse, to bet on a horse which locks you in. Let's say, for example, start to fine-tune some model where you think it's going to rule the world. No, forget it. Do something more pragmatic, go faster, absorb it, consolidate it, create value. That's kind of how we deal with that.
Can't build an agent without an ontology. The better the models they get, the better the agents get. So that's my hypothesis. Prove me wrong.
More questions?
Grab a mic or, oh, thanks. Hi, my name is Nemo. I run manufacturing in China, so I come from the traditional world. I'm seeing in software that with like Cloud Code and a lot of the more advanced tools, a lot of the work of developers, programmers was kind of automated. It can be argued to what extent, but many people say that a large portion of the work was automated. We have teams of engineers working on CAD, working on SolidWorks and other programs, and I'm wondering when this next step will be taken in the CAD world, and what are the bottlenecks? Is it the amount of data? Is it the type of work? When will we see tools that are similar to Cloud Code and others within this physical space?
I hope soon, but I'm skeptical about it, honestly. So the thing is, you know, these coding copilots work because you have GitHub and you know, text and code out there, and this is basically what these models are trained on, right? CAD is, the funny thing is with CAD, it's basically IP of companies, right? Because it's a digital representation of their product. So they want to keep it to themselves. In architecture, actually, it belongs to the client. So if I have an architect build my house, like I own this plan, so they cannot just do anything with it, right? So it's a data bottleneck, to answer your question, right? So you cannot, on scale, feed data to come up with a generic model on CAD. I guess, you know, we talked about physical models real quick, right? I think they talked about it a couple of days ago. So yes, physical models is the new big thing. There are big projects, Project Prometheus with like 6 billion and Jeff Bezos and everyone behind it trying to solve this. We are, of course, following this and hoping that it works, because then we can plug those models in as well. But to be honest, yes, like technical drawers maybe will be disrupted within the next 3 years. But being in charge of something, again, that needs to work in reality, where people have to trust these things, will always have, engineers and designers working with CAD. But hopefully it is just way better and way faster.
More quick answers, because we're getting to the end of the session. You want to answer quickly?
No, I think the question was mainly about CAD, so I think I'm fine with what you said.
Thank God.
Good. So that would conclude the panel discussion. Thank you very much to the 3 panelists and their very good insights.
Thank you.
Thank you.
All the discussions that we have here at the AI House, they must continue. And not only next year, in 12 months from now, but throughout the year. It's an ongoing dialogue. And that's why we are very much supportive of initiatives such as the Davos Tech Summit, who we'll be learning a bit more about in a second, where very much a deep dive on physical AI is being done. So in the next half of today's event, we want to learn a bit more about why we're doing this. We want to provide an outlook and already maybe get the first insight. So we'll get a first trailer to get into the mood, and afterwards we have a conversation with Rebecca Brauchli from the Zurich University of Applied Sciences, Nadia and Davide. But first I'll step away from stage and we'll see the trailer.
Good morning, everybody. Thank you, Jeanette, for this nice introduction. Thank you for making it possible that we are being here from the ZHW, from the FH Graubünden, and from the University of Zurich. We were just waiting a couple of minutes, but I do have some introduction words for you, so we can use the time to wait till Davide is back. So, good morning, everybody. A warm welcome from my side as well. I'm very happy to be here. My name is Rebecca Brauchli, as Jeanette already introduced myself, and I'm representing ZHW. We're this year official partner of the AI House Davos, and we're very happy that we can be here. Moreover, we are closely involved in the realization of the Davos Tech Summit. We will talk in the next couple of minutes about this event taking place in summer. Maybe you haven't seen it because it was in the bottom, but there is also a panel, so you can register and find more information on the internet. So thank you very much. It was a pleasure following the inspiring discussion from the panel organized by the FH Graubünden. And we now move from local innovation to a broader horizon towards a topic that connects Switzerland, technology, and Davos in a very concrete way. And Davide, you're just in the right time. Welcome, Davide, on stage. I'm very happy to move now officially to our fireside chat with Davide Scaramuzza and Nadia Christoffel. And this conversation brings together cutting-edge research and local actors, and I'm very happy about this. First, I'm delighted to welcome Davide Scaramuzza. Davide is one of the world's leading researchers in robotics and autonomous system and professor at the University of Zurich. By the way, University of Zurich is also partner of the Davos Tech Summit, and we have Ruben here from the EthonAI initiative of the University of Zurich, and you can talk to him and to Davide as well later on. Davide, it's great to have you here. Joining the conversation is Nadia Christopher. She is responsible for the regional development here in Davos and Prättigau. Thereby, she plays a key role in connecting innovation development of Davos. Nadia, wonderful to have you here.
Thank you.
So, Davide, let me start with you. I heard that you have broken several world records. Could you briefly tell us about them and what they represent from a research perspective?
Okay, maybe a few words about my background. I've been working in robotics for 22 years, first on autonomous cars, and then 15 years ago I decided to move to drones. And in particular for GPS-denied navigation of drones for applications that span from inspection of bridges to power lines to now even container ships. And one of the biggest challenges in robotics, not just drones, is that we want eventually robots to be helpful to us humans, so they should be more productive than humans. And so for drones, that means also flying fast, because especially a drone that flies faster, it can actually fly longer distances and therefore maximize its productivity. So how can we researchers push the limits, especially in perception, planning, control, and machine learning? So almost 10 years ago, we came up with an idea to gamify our research, and we thought of using drone racing actually as a way both to attract talents, students, motivate my PhD students and researchers, put everyone together on a cohesive big vision among other projects that we had, and we got a lot of funding from the European Union, from the Swiss National Science Foundation and Intel. And then the big vision was that we wanted to build an AI that would defeat one day the world champions of drone racing, because drone racing is a sport where you put all your skills at test. And in the past, AI only won on chess, then Go, or video games. And so this was really, truly difficult to achieve. So it took us 10 years. And then in June 2022, we invited to Zurich the 2 world champion drone racing pilots. And we weren't sure we were going to win, but our AI won 15 out of 25 races, and it also recorded the fastest lap time. It was also the first time that an AI defeated a human in a physical sport. So this is actually the one record. Why was this important? Because it was not just for fun, obviously, it was for research. It was actually a proof that when you push the limits, it's possible to actually have decision-making systems in the physical world that can do better than humans. Does it mean that now the game is over, AI is better than humans? Absolutely not, because this was a game, so in a controlled environments, controlled lighting, controlled aerodynamics, and so on. So we overfit specifically this task. But it shows that you can build reliable systems for the real world that are also safe.
Thank you very much, Davide. I had the pleasure to see flying your drone, so it's really, really impressive. Thank you very much. Nadia, when you hear about these drones, AI, these records, what comes to your mind, both personally and from the perspective of Davos?
Well, personally, as a kid, I loved the Jetsons. And sometimes in my daily life, I wish I had a Rosie. And when it comes to technical development and engineering, I'm very enthusiastic. But on the other hand, and to stick with comics, I share Uncle Ben's belief that great achievements come with, and great power comes with great responsibility. So when it comes to records, I don't care about the fastest, but what is its purpose? So what it is used for. And I think that's important to think about. And also in the perspective of Davos, and what is the purpose of those who sell it, those who use it, and those who buy it. And I think that's important to think about sooner than later, because when it can be used in collecting samples for research, when it can be used to fight fires, I mean, then it can be used in an opposite way. and it's critical, and we have to think about that. And especially during the World Economic Forum, there is a huge security stuff here, and it's very difficult to control. And I mean, yeah, as you said, robotics is more effective sometimes than people, and this is for a mean way as well. So we have to care about that too. And this is what comes to mind when I hear about the records. But congratulations.
Thank you very much, Nadia. I know you as a critically innovative person, and I really like that. Davide, so let's deeper dive into the main theme of this fireside chat, but also the main theme of the Davos Tech Summit. It's physical AI. First, what is physical AI for you, and where is Switzerland strong in this field?
So physical AI means an AI that can interact with the physical world. So it also means that it has a body that allows it to interact. So this is basically robotics, but robotics with a common sense. So LLMs, so large language models like ChatGPT, Gemini, and Claude are very good because they've been trained on every possible text produced by us humans in the past centuries, everything possible. And they also have common sense. So you talk to, you interact with them, and they can actually also predict analogies that we humans sometimes don't even think about. And so many people, especially philosophers, technology enthusiasts, they think that because we have had our ChatGPT moment, now it should be the time for the physical AI moment. And the reason why this is not possible is because you cannot train a robot agent on every possible action, because there are more actions existing than data sets. So you see, neural networks are very good at interpolating. So language models have been trained on everything. So they interpolate between data points. So they put the entire world in a box. You cannot put the whole set of actions that we do every day since we are born, our ancestors was born, and our kids will be born into a box. So we need systems that are able to extrapolate. However, at the moment, we see these big companies, for example, Physical Intelligence from Berkeley, from a very good colleague of mine, Chelsea Finn, that are betting on, they're trying to build systems that interpolate, and they have collected thousands of human demonstrations to allow humanoids, or at least robots with 2 arms, to do things for home tasks like folding clothes, loading and unloading the dishwasher, that look realistic to us. Very slow, but actually they start to work. And now there are rumors that basically they want to increase the number of human demonstrations to a million human demonstrations. And now there are also companies like Google, for example, that have discovered very recently that video foundation models are also good for robotics. So these are basically foundation models that have been trained on all possible videos and movies, all the billions of movies that people have uploaded so far, and they're actually good at predicting actions, and they can be used to some simple tasks in robotics. So at the moment the question is open, but remember, we will not have systems that will extrapolate, okay? They will have to interpolate like we did for ChatGPT. So this is still an open question. When will this system when will there be a ChatGPT moment for robotics? And nobody can really answer this question. What we can answer is that there will be a ChatGPT moment for certain robotic tasks. And then where is Switzerland in this whole ecosystem? Well, Switzerland is very good, for example, in robotics. It's been often called the Silicon Valley of robotics, or the Silicon Valley of drones. We have more than 150 drone companies in the greater Zurich area, and also including Lausanne. And then also it's very strong in LED robotics and also machine learning. If you now consider, normalize the amount of researchers and companies by the country's population, I would say it's the top in the world. So Switzerland will always be leading in terms, I think, in innovation.
Thank you, Davide. And the follow-up question here, why is that so that Switzerland, or maybe even greater Zurich area, is so good in that, or innovative? Do you have an answer on this?
That's my personal answer. First of all, we have very good schools, of course, ETH, University of Zurich, EPFL, Lugano, we have IZIA that pioneered the LSTM, recurrent neural networks. A lot of talent. And also there is a big collaboration between the university and startups, also thanks to Fachhochschule. By the way, this is also a very unique system that we have in Switzerland, we don't have in Europe or in the US. And there is a lot of attention to practical applications that will improve the economy. And this means also that you need a system, a political system that is stable, and also both politically and economically. And we know Switzerland being one of the most stable countries in the world, politically and economically.
Thank you very much. This stability is I think, also very strong and very different from other parts of the world, obviously. And hopefully we can keep that. But let's look ahead a little bit, Davide. Let's have a look into the future. You just said before that you cannot make predictions and you cannot predict. I'm sorry. You cannot predict when will this ChatGPT moment for robotics, but still, I have the question, when will we start living and working with robots, and in which areas they become most present?
Yes. Well, we are already living in a world surrounded by robots. We just don't pay attention to it, but robotics is being used a lot also in agriculture. You know, the world population is increasing, it's projected to reach 12 billion people by 2050, and we need to feed all these people. So we already have vertical farms, and drones are already being used a lot to water these plants and so on. So agriculture is one of the fields where robotics is already playing a role and will play an even more crucial role in the future. Logistics already playing a role. Think of the company Verity, which is one of the most profitable robotics companies in Switzerland. They use drones for warehouse inventorying. For example, IKEA, they have hundreds of drones navigating at night and scanning items in order to reinventorize IKEA warehouses. Also, Amazon has been using now robots for more than 15 years. They have tens of thousands of robots all around the world. At home, so many, there are many people that also speculate when will we have robots at home. We don't know. I mean, people like Elon Musk, of course, they have to sell their robots that they project that they should be coming even as early as in 2 years. Is this true or not? It can be true. I mean, there is some possible truth in that, depending on what you expect the robot to do at home. So if you're talking about the simple tasks like folding clothes, loading and unloading the dishwasher, if the robot is actually much more competitive cost-wise with respect to your person that comes to your home, once a week, why not? Why not buy? So this is a possibility, but I do not believe we will have soon a humanoid that will be helping us in every task at home. Also because these robots still lack a lot of common sense. A very simple, stupid example. Think of a humanoid that is pouring wine or water into a cup. It has to predict that the water can spill over, and then if there is a laptop or an electronic device nearby, this could actually be dangerous. And now, would you have a humanoid playing with your kids around? I mean, how do you train all these robots? Who provides the data? We will be providing data, but the moment we start accepting these robots into our homes and then uploading the data to the cloud so that these companies can actually let them improve. That's exactly the system that Google Waymo has been doing, for example, for the past almost 20 years to reach level 5 autonomy in Los Angeles and San Francisco.
Thank you very much, Davide. And my final question to you in this panel for the moment, before we become even more local, what role can play Switzerland in this future, specifically? So
I think, again, Switzerland will play the key role of driving the innovation, technology, especially in research, a lot, because we have a lot of funding coming from the Swiss National Science Foundation, and also thanks to the European Union, a lot of, especially for civilian applications. I worked in the US. A lot of research is being driven by military applications. So we have this kind of opportunities here in Europe and in Switzerland. And again, driving talents, attracting talents with a lot of interesting projects and so on. And also especially the cohesion between academia and startups and other companies.
Thank you very much. So let's do this in future also with the Fachhochschulen to build a bridge between research and industry. Thank you very much, Davide. Nadia, why does this topic, so physical AI, robotics, why does it matter for Davos?
Well, actually, Davos has a long history as in exploring, in pioneering. So it is a floor where you can test and develop things in a small scale city. So we have startups here that we're working in AI, and of course this is a reason for us. But still, Davos is a small town, is a small city where you can test and try, and once a year it becomes global. It's when the World Economic Annual Meeting is here. On every corner of the world, people are here, and there is a possibility to show what's going on. And this has impact on the brand of Davos, and therefore it can influence a platform as the Davos Tech Summit in a positive way. And also, on the other hand, it is important for Davos to be seen, and for our startups to be seen in this context.
Thank you very much. I very much agree with this, because I know the mountains, I know Davos from my childhood actually, and I think it was very much the case for the last, I don't know, decades, that Graubünden and Davos was always very innovative. So you could really attract people to come here and be innovative, and I really like the spirit. Thank you. So I have problems with my cards, as you see. So Nadia, another question for you. You already talked about, or we already talked about the Davos Tech Summit, and you are really involved in this summit in summer, taking place in July. How does specifically this summit connect to the long-term vision and development of the region of Davos and Prättigau, Graubünden maybe?
On one hand, we want to strengthen innovation, and that's a strategical goal. And on the other hand, it takes place in summer, where there are not a lot of people. So we want to strengthen also the whole year, and we are an established meeting place, the world's finest meeting place, and it strengthened this as well. So we use this brand to build a new platform and to make for new dialogues in technological development.
Thank you very much. I think a lot of us experienced this. That Davos is a very nice host city for international global events.
We try our best.
Yeah. So
but if you can, please come by train or walk. would help. Walk
from Zurich, okay.
No, but no cars.
Yeah. No cars, yeah. I'm just joking. Thank you very much. So the next part of this fireside talk or this session will be that we make physical AI even more tangible. So it's not only a word, but it's also we can interact with physical AI. But while we are waiting for this surprise, we have time for questions for Davide and Nadia. So is there any question? Ruben, go first.
Thanks, and thanks so much for organizing this amazing event. It's super cool to be partnering, and it's nice to also indeed visit Davos again in the summer, next to skiing in the winter. So what I've seen around the topic of AI is that companies are actually taking over more of the role of universities on the topic of fundamental research. And while there are indeed these instruments, European Union, Swiss grants, etc., that still stimulate fundamental research, which was traditionally reserved for the universities, there's so much money and potential in the locking effect of becoming the physical AI player, that NVIDIA, OpenAI, etc., are pouring millions, billions into development of these. So how can you stay relevant on these topics as a university? And I think that's my question.
It's a great question. And I face the same question too. to be honest, I try to answer what is the role of academia, universities. I think academia is a gym where basically we come up with crazy ideas and then we develop them, not because of some research agenda of some company. So we are free. But there is actually a key advantage of academia. We can publish at any time we want. A company will never publish at any time they want because they want to have, they only publish things when they're truly sure that this is going to have an impact and it's at the right moment and so on. So think of AlphaGo. AlphaGo didn't, come in multiple pieces. In academia, typically, they don't publish one research paper every few years. But that's what companies are doing. They publish one paper every few years when the project is truly completed. What does it mean for other researchers? The other researcher will not be able to benefit of your progress until that research is finally completed, until you publish it. That's a pity, because you want to be able to share these at conferences, so through research papers, while you're working on it, so that other people can help you and you can give it back. So it's based on being altruistic in academia, and this is something that will never happen in companies. It's not happening at all. They're always waiting and delaying the publication of research results until they are done. But if you don't want to talk about that, it's true that they can definitely compete also because they are offering a huge amount of money for research interns and getting the best talents to work with them even for 3 months or 6 months. For this, of course, it's very good, profitable for the company. In terms of GPU research infrastructures, I disagree. I mean, now if you consider Switzerland with the Alps cluster, we are actually positioned very well to compete also with the other companies, provided that you have booked enough GPU hours for your experiment in advance, but it can be done. I mean, look at Apertus. It's a great research achievement in Switzerland, thanks to the Alps cluster. So no, but I repeat what I said at the beginning. Being a gym that allows to come up with crazy ideas, put them in practice, and especially publish continuously, not at the very end after 6 years.
And maybe we are a gym in Davos as well for that, not only at the university. You don't have to reply. I realized that it was not a question for you, but I just was thinking about Davos as a gym. I like this idea.
Me too.
Other question? Maybe you go?
Oh,
sorry.
Very practical one. So I also have a AI startup and was briefly thinking about incorporating in Graubünden, but the incentive was not really there. So we had to, we settled for Zurich and San Francisco. And in the meantime, I would love to know what is something that you could offer if I start the next company tomorrow that is really tangible and helps for the first, let's say, couple of years, given that we're not with a university, so it's not the spin-off idea. It's really just starting fast, something that the US offered us.
Well, we are not, how you say that? There are possibilities, but I think it's not that amount of money as it is in the US, and but we try to support. So if you are having the idea of creating a new startup, you give me a call and we sit together and we find solutions, because Deal. This is what we do. Deal. Okay.
Deal. Okay. Okay.
Very nice.
Anyone else? Next group.
Is that connected to this question or a new question? Okay, go ahead.
Sorry. All right. So, what do you think is the biggest opportunity for governments and corporations to monetize, whether it's robotics or drones?
Sorry, can you repeat the question?
Sure. What is like the biggest opportunity between drones or in the physical AI? Like, would it be drones or robotics for corporations or governments to monetize?
So drones, robotics. Drones are part of robotics. Well, I would say both, but I mean, let me clarify. At the moment, the drones are being used a lot, so many people now link it again to military applications, but the word drone was initially invented during the First World War. But, you know, in in the early 2000s, drones actually started to be used more and more for civilian applications until 3 years ago, and now it's actually again more for military applications. But let's not forget that drones are already saving a lot of lives by continuously, daily inspecting our world infrastructure, bridges, power lines, combustion chambers of power plants, and so on. So in the US, they estimated there are more than 40,000 bridges at risk of collapse. And this is because of climate changes and so on. So robotics, not just drones, are already being used to actually make this inspection, becoming actually much more frequent than before. So this is a big opportunity to invest, in maintaining our infrastructure. So much more than the domestic home robots. That's my personal view. Cars are already saving a lot of lives. I think the European Union published a report that 2 million lives were potentially saved in the last few years thanks to modern smart cars that are not level 5 autonomous, but level 3 autonomous. So these are opportunities to invest on.
Thank you very much. There are other questions.
Hi. I'm an investor in a company called Flytrex that does drone deliveries. And that company and others, I'm sure, are now suffering from the trade wars with China. As you probably know very well, a lot of the parts and components for drones and robotics in general come from China. It's very difficult to export anything related to this industry, including magnets or motors or anything like that, outside of China. I'm wondering if there is an opportunity in Europe, Zurich, elsewhere, and if you see this industry shifting and moving away from China elsewhere.
Yes, I hope that there will be actually companies being built in Europe that will produce all these key materials that we need for drones, so the magnets, the coils, specifically, they are at the moment coming from China. It is true, we are all depending completely from China. But things, for example, during the Ukrainian war are changing in Ukraine. I mean, they founded more than 1,000 startups that are trying to actually overcome the dependence on China. So this is possible. So it's an opportunity. But it took a war. But we know wars have propelled technology and innovation, unfortunately. The fruits of war.
Yeah, that shouldn't be the case, of course. Thank you, Davide. Maybe we have... yeah, it's just our surprising guest is arriving, as you see. But maybe we have one last question from the audience. There is one.
Yeah, hello. I have a question for all of you, actually. So we're working in the field of manufacturing machines, SME, close to Bern. We have an office here in Davos too, a small one. And I would like to add to Nadia's, I would call it optimistic criticism. I think something was like that, like in a critical question formulated. Why should ETH or ZHW or whoever come up to Davos with the students? I rent an office here. It's incredibly difficult to find a spot. How do we make Davos more attractive for that? And how do we encourage students to come up here to spend and make their bachelor, master thesis or whatever, and ideally grows into startups? Ideally, there is the ecosystem of startups developing in the Alpine that not just come for the skiing and enjoying the nice scenery and mountains, but how do we achieve that? It's a tough question, I get it, but it should also be an incentive.
We are working on that. Just yesterday we had a discussion about that, because one of the challenges in Davos is we have research institutes that have a longer history than skiing. So we do research longer than we ski up here, and there's a lot of potential, but it's difficult to find talent who comes up here. So it is about promoting. It is about promoting the places where you can work. There are offices, there are places where you can work. It's difficult for construction sites, so it's difficult for a fabric or some where you really have to produce something. But we have room, we have space, and it's not known that well. And everybody knows Davos for this week in the year. Everybody knows Davos for skiing. But do you know how the weather, the sun, the no fog impacts your creativity, impacts your well-being, the dark nights, how it impacts your sleep, and how this impacts your results and your capability of working. I mean, it's a great place to study here. It's a great place to test. And I mean, it has this spirit, and this is why the World Economic Forum wants to be here, because it has this spirit of pioneering. It happened here where they started, they thought about how the climate impacts the treatment of tuberculosis. So it started here, and one had the idea, and it started and became a huge thing, skiing as well. I mean, it started small, but it can grow. And I think if we put our heads together, we find solution how we can promote that. And I mean, you tell your students where they can write their thesis. I mean, look around. You work till, I don't know, 5 o'clock, and then you run up on a hill, and you have this clear view. And then you go back and you work till 5 o'clock in the morning without any problem, because you have the energy. It gives you a lot of energy. So we really have to promote this too. And I'm trying to make more. I'm working on some projects that make all we do more visible and all the places we have. And it can be a very interesting and interaction with all. We have different research fields here, and it is interesting if you can connect to others. So there is the communities here. You just don't know them yet. So maybe we start building these bridges and make Davos attractive for students and talents and startups.
Yes, please. Yeah,
I do.
And we try from ZHW to support your idea, being in the mountains and study and have a free mind to think. Thank you very much for this question, all the questions. Thank you very much for your passionate answer. We really felt you. Thank you. So we're just right on time for a special guest. I'm very happy to welcome Pascal Kaufmann. He's the CEO and founder of Mindfire, with one of your humanoid robots. So we can really interact with physical AI here. Maybe I'm promising too much. Pascal, you are one of the main drivers behind the Davos Tech Summit. You can please stay seated here, and you can take a seat, Pascal, there.
All fine. Say again, I was carried away because I saw it only many months ago, the last time.
So yeah, take a mic and take a seat, please.
Okay, I'll do that. So she's my assistant. Her name is Henrietta. And she's sometimes a little bit moody, so I have to be careful what she's doing. But at the moment, she behaves, so all fine, yeah.
But what does she do when she's moody?
She has an autonomous modus, so she can actually follow people when you have like a Bluetooth sensor activated. And then she sometimes takes shortcuts, so she doesn't pay attention to obstacles. So that's a little bit an issue sometimes. And moody also means that when the battery is empty, then she doesn't do anything at all. And yesterday we had to send a rescue team here to the AI house because it's an 80-kilogram heavy humanoid robot was out of battery, and 4 people had to carry this robot into a wheelchair and bring it back to our lab. So this we have to be careful of. Yeah.
Hello, please check the network.
That's not her voice. That's the voice of the operator.
Okay. Pascal, thanks for being here. And so we go back to the very beginning of our chat, before we really dived in the physical AI, into the Davos experience, and come back to the Davos Tech Summit. So as I said, you are one of the main drivers behind the Davos Tech Summit, and we are launching the first edition of the summit, as I said, this summer. Why the focus on physical AI?
And why Davos, maybe? I would have loved to say something to add to you, to compliment you. I'm a big fan of Davos. I mean, it's so exciting here. I mean, you have Elon Musk here. You have all the top shots in the world all coming to Davos. For a talent that works in robotics, I mean, the talent needs wireless, like a good infrastructure. This we have in Davos. But here we have like a science city. We have the leading research institutions globally here in Davos. You can have sports. There is politics if you like to do, right? And I don't need a city when I like to do amazing work in AI. I need good infrastructure. And I think this all together speaks a lot in favor of Davos. And why physical AI, Rebecca, right? Davide and I worked in the same artificial intelligence lab. Also from Davide, I was taught that the body is super interesting for intelligence. So when you look at the human body, a lot of intelligence is actually outsourced into the body. And the blockage that we have in AI is because the AI is not embodied. Therefore, I think the next stage in real human level AI should be embodied intelligence, physical AI. And that's the reason why we equip these kind of robots with AI algorithms, so that they also become useful in the real world. And okay, yeah, we know that she's offline now. Yeah, that's the reason. I think the last frontier to create really human-level artificial intelligence is embodied AI. And the drones, for example, have a kind of a body. The robots have a body. Just algorithms on a flat screen will never bring us to human-level useful AI.
So I know you as a very visionary mind. And when we jump like 10 to 15 years into the future, how will it look like?
Oh, I have to be careful here, because I could say everywhere will be humanoid robots, right? But I was also taught by interesting people that told me, Pascal, forget about humanoid robotics in the next 10, 15, 20 years. So why is that the case, right? These robots are by no way compliant. I mean, if such a robot crashes down to a little baby or like an elderly person, the person instantly is crushed, and it's very dangerous, by the way. The robot, they have spy algorithms. It's a Chinese combat robot, what we have here, right? You would never, ever put such a machine into an elderly care taking home. Until these robots get really compliant and not dangerous, it might take a lot of time, because you need to make the robot a little bit lighter so that it's not dangerous, but then the robot cannot carry around anything because of the weight. And I think in a non-regulated environment, like in other countries, yeah, of course, you may have robots. You already have self-driving cars that bump into walls or carry over people. But in a regulated environment like in Europe or Switzerland, I would be a little bit skeptical that these robots make their way soon into our kitchens. I think the robots they are just not there. But I don't want to contradict the experts here on the panel, but my view is a little bit a more conservative one, yeah.
Maybe you can add something, Davide?
I 100% agree. Indeed.
Actually, this is very rare. Davide and I appreciate him a lot. Sometimes we have different views, but I think there we are aligned, yeah.
Absolutely. I mean, it took us, we still don't have autonomous cars. I remember in the 90s they promised they would come in 2000, then in 2000 they promised they would come in 2020, and now they're talking about 2060 for level 5 autonomy. So for this humanoids, probably we have to wait another 40, 50 years. But I would say we can have also level 1, level 2, level 3, level 4, and level 5 humanoid robotics, and some homes will be more excited to test this technology than others. So there will be a slow adoption starting from some countries that are more open or less regulated and so on, and then the other ones will take over. Now, like now Switzerland with the level 3 autonomous on Swiss highways, in principle.
Just a little anecdote. I mean, 200 years ago, they also had robots that looked like human beings, right? And when you look at Henrietta, for example, it's super impressive what these robots can. I mean, you can push her and nothing happens. Right? She's super robust. This robot is super robust, and it's really impressive when you look at this. But it's just a wonder of mechanical engineering. There's no intelligence at all. But people are carried away and think, whoa, we have human-level AI. This was the case already 200 years ago, or Sobor 100 years ago. So whenever you see humanoid-like thing, you think, we are near there. So don't be fooled, please. Don't fall for the US or Chinese PR. These robots are nowhere close to be useful.
Thank you. Thank you for this presentation, your statements. Maybe we have time for another round of questions. Yeah? Here.
Hi, I'm Aga. I'm VP of Women in Data Science. Thank you for interesting panel. Thank you for bringing Henrietta. I actually met her also during the Swiss AI Summit.
She's a world star. She was in Chinese and Indian news yesterday night. So yeah.
Yeah. I have a bit of philosophical question, to be honest, because I totally agree that we're nowhere near robots helping us at our households and so on. So why do you believe, where does the need of creating humanoid robot come from? Because like helping us in doing dishwasher, as you've mentioned, or helping elderly people to come from one place to another, we don't need a humanoid robot. We can just use like ABB is already producing the kinds of very precise robots with sensors, arms and everything. So why humanoid? That's a kind of, that I would like ask from the philosophical, as I said, point of view.
It's a great question, by the way. Why humanoids? And I actually also face this question because there are many companies that are now investing in humanoids for logistics and transporting goods from A to B on environments where there are no steps, no staircases. So why do you need a humanoid? They don't need humanoids, okay? And also, what is a humanoid? In the news, sometimes they refer to drones with 2 arms but no legs as a flying humanoid. So at the moment, the humanoid became a little bit a synonym of robot. But by humanoid, we mean an anthropomorphic shaped robot. And the reason why they are all these big investors are betting on humanoids is just because the expectation, and it's a hype, will be that these machines can navigate in all the environments that are built for humans, with anything. So if you have to push, for example, the wardrobe in your room, you would like the humanoid to help you push it further. You may want to use legs so that you can actually, lean with your body center beyond the 2 legs. And this is something that, for example, a wheeled machine will not be able to do. So it's more about the things that it could actually do that are more similar to humans than other things. But I agree with you that for preset environments, there is no need of legs. Or you can have a special wheels that can also do legs. And Switzerland is leading the ecosystem in that.
I'd like to add something to that. One of the oldest dreams of humankind, the oldest saga in the ancient Greek mythology is the Prometheus saga, where a half-god tries to create a human. It was always the dream of mankind to be able to build humans like God. So this is one of the last frontiers, to be able to build an artificial human being. Definitely, I think the way to real human-level AI includes a body. Therefore, the Davos Tech Summit is so important. One way or another, we need to have robots in our society. But the question is when. But it is the oldest dream of mankind to be able to build artificial human beings.
So first of all, thank you for this insightful panel. Just building up on that, where do you see the AGI and maybe from a time horizon perspective, how feasible it is?
I can go first because it's always the same question, right? And I asked exactly the same question 2 days ago. We handed over the Global AI Award to Björn Ommer for his algorithms. I hope he one day may win the Nobel Prize for his invention. And I asked him how long to go until we have artificial general intelligence, right? And I asked this also Jan Lecker, Demis Hassabis, all these people, I ask them every year. And I think there's a consensus that says the GPT models that we have these days are super impressive. So from that perspective, they are quite general because you can ask any kind of question. So in my humble opinion, I think we are already there. Of course, now we can define, and there are edge cases where the GPT technology is failing horribly, right? And it's really not just the real thing, it's stupid statistics, but obviously stupid statistics is sufficient to replicate brain functions. So I think we are rather close. But here I think we may differ, Davide, I don't know.
I take Jan LeCun actually answered that you're very, very far. We don't know when we will come. Some people like Jürgen Schmidt-Huber believe it's a matter of depth of layers and they will emerge spontaneously at some point. I don't know, to be honest. And remember what I said at the very beginning, that one thing is AI, another thing is physical AI with a body. You cannot put the entire world of actions into a box and then train these systems to interpolate because you need a lot of data set. But then, of course, if you have something that is general enough that you can put it in the wild, then it can start learning by itself. I don't know when that can happen. It can be in 10 years, 20 years, I don't know. It can be tomorrow. I cannot make predictions because at the moment the research has not yet discovered artificial general intelligence.
He said can be tomorrow. So that's great.
Yeah, let's see. Thank you very much. Maybe one final question from the audience? Or are we, yeah? No?
Can we do some PR for the Davos Tech Summit as well, or is this already done? PR for Davos Tech Summit, has this already been done?
Yeah, you can add some PR, of course.
Okay. So while I'm here, I like to invite you in summer to join the Davos Tech Summit. We will invite the 30 leading humanoid robots in the world, and we like to display to you what these robots are actually capable of.
Hello.
It's super interesting. I think they are picking up stuff, and sometimes they give their opinions here. But I definitely think in our lifetime, robots will play an important role, and it's important that Switzerland leads this development, because this is we are ideally positioned between China and the US. We take the hardware from China, we take smart people from the US because they all want to go now to Europe, right? And here in Switzerland, I think we have the ideal conditions to lead this field here. Also with distinguished research like Davide, who has so many world records, even on Mars. They used your stuff, right? The helicopters from Mars were powered by Davide Scaramuzza's algorithms. Switzerland is definitely leading in that field. And yes, if you want to have a glance where we really are, I think the Davos Tech Summit is the ideal opportunity. And you can sign up for Early Bird, and it's a website there. So please join us and see where the hype really is. Yeah. Okay, this was a little bit of PR. Sorry for that.
Thank you. I add we are very happy to welcome you in summer here in Davos. It will be a great opportunity to connect between academia, our university, with ETH, with the University of Zurich. Even SUPSI will take part. So a lot of different universities. I'm very happy about it. And also people from industry, students, young talent. So everybody should be here in Davos in July. And I'm just hand over to Janet. And thank you very much, Davide, Nadia, Pascal, for being here. And thank you, Janet, and to the team of the AI House to making this possible.
Thank you. Also from my side. So as I mentioned in the beginning, we still have breakfast in the back. We'll stack a few chairs so that we can also network. But Switzerland, being the strong ecosystem it is, will actually, once you have gotten the chance to stand up and move towards the back of the stage, we have another event that we would like to present to you. Next to the Davos Tech Summit, there's also the Zurich AI Festival that's coming up then in fall, and we'll also see a quick trailer here before we then move to our really nice breakfast. Enjoy, and thanks so much for being here. I think this was an awesome finish to the AI House Davos 2026.